Welcome to Data Skeptic Time Series.
This is Data Skeptic Time Series, the podcast about how to predict the future based on historical sequential data. Episode number. In my opinion, the best way to get started with time series forecasting is to just start doing it. Find a data set you're familiar with or study one, and start trying out the various algorithms you can find. And then see how they perform as you start deforming the historical data. If you want to do this in R, you should check out some of Rob Heineman's packages we discussed last week on the show. If you're a Python user, I recommend you check out Darts. Today in the show, I speak with Julien Herzen, one of the maintainers of this Python package. We talk about the motivation, design, and functionality offered, and how you can get started pretty quick using it in your own projects.
My name is Julien Herzen, and I work for Unitate, which is a Swiss data science service company.
I had invited you on primarily to talk about a Python library that I've been working with a little bit, that you were one of the maintainers and I think original author of, and that's Darts. What's the high-level pitch for Darts? What is it and why do people like it?
So Dart is, like you said, is a Python library whose primary goal is really to make it easy and straightforward to forecast time series, but also we have a vision for it. We want to do more than forecasting, so we want to just make it easy to work with time series and do all sort of other stuff like also anomaly detection, etc. But for the time being, Darts is really time series forecasting library.
And from let's say a software engineer's point of view, someone who has a time series problem, but maybe not the academic background in ARIMA and this sort of thing, can they use this tool?
Yeah, that's actually the goal, one of the goals, to really make it easy and to lower the barrier of entry for building and using forecasting models, and also testing these models, comparing different models, and just basically experimenting with different forecasting approaches. Hopefully it's easy enough. We are really trying hard to make the libraries as easy as possible to use without compromising too much on the functionalities, which is a challenge in itself, I would say. But ease of use is really the main thing we are trying to optimize for.
Well, let's imagine I've got some time series data in my hands. For me, maybe it'd be podcast download numbers, but it's some business or nonprofit. It could be website visits or something like that. And that's, I don't know, in a database or a CSV file. And I'd love to get some maybe forecasting out of it. How do I move from my data into a model using Darts?
That's a good question and a fairly general one. I think the first question to ask yourself is really, what do you want to do? What are your, I would say, high level or even maybe business goals that you have with this data? Perhaps you already know that you want to forecast. In that case, probably it's good to ask what matters, what are good properties that you would like these forecasts to have, that will, I think, help evaluate any final solution that you may get. And then, because you're very concrete and asking about CSV and databases and so on, I think here the basic thing to know about Darts is that it mostly builds on pandas, and it has basically one important type, which is called time series, and it's a wrapper around pandas data frames. So whenever you can express your time series data in a data frame, you're mostly good to go. You just have to make sure it has a proper time index. It can be actually treated like a proper time series. If you don't, Darts will yell at you basically when you try to build a time series. And then once you have this type built, you're good to go. You should be able to use most of the models more or less out of the box. So basically then using the models works a lot like scikit-learn. So here we haven't tried to reinvent the wheel. It's all based on these nice fit and predict interfaces. So first you fit your model on your data, and then you predict on new unseen data. And here, just one more word, we have basically broadly speaking, two kinds of models. We have the ones we could call the classic models, so the ARIMA, the exponential smoothing, and models like that, which usually are fit on one time series only. And the goal is to forecast the future of this one time series. And we also have forecasting models, which we call global models, because they are fit on more than one time series, on multiple time series. And these are currently in the library, they are mostly neural network based models, deep learning models. And those ones you can fit on multiple time series. And you can also make them predict the future of time series they have never seen during the training.
Very exciting. So the full end-to-end experience then.
That's the goal. There are lots more things that we want to build in the library. It's very much work in progress. I think we're still rather at the beginning of, of the story. But yes, I think in terms of forecasting, we come close to providing sort of end-to-end experience.
So Darts is fully open sourced and also kind of bundles together some existing tools. Do you have any advice for how people install it? And are there any cautions about use cases for how to use it, even though it's open source? Can I run this in a company? What are some of the opportunities for people to pick this up and use it?
It's fully open source, so there are not basically drastic constraints. It's a very classic open source project. The license is an Apache license. So, maybe if you really are serious about using it, I would recommend that you at least read maybe once the license or the gist of it. But there is no surprise, nothing special there. It's really just a classic open source project. And to install it, I think it's also very easy. If you're used to using Python, it's nothing new. Just create any virtual environment using, virtualenv or conda or anything like that. And then you can just type pip install Dart and it should work. We also maintain some more lightweight versions because the full version has quite a lot of dependencies that can be a bit heavy. So if you have constrained resources or you don't want to use too much disk space, you can also install an alternate version, which is called U8 Dart, which come in different flavors that are a bit more lightweight. But I think for 99% of people, just pip install Dart will do it.
Yeah, and on the GitHub page, it's about 20 lines of code or so, and you'll be up and running with a model. So very accessible in that regard, which I like because then it leaves me more time to spend where I think I need to spend my intellectual time, which is figuring out which model to use. Given that there are so many available in Darts, do you have any advice for how someone can decide where to begin and maybe how to explore those?
I think you nailed it exactly. Well, that's the exact goal of the library. Actually, we sort of build it almost out of frustration, I would say, of losing a little bit time on the specifics of each of the model. And we really wanted a unified API that would allow to easily switch one model with another without rewriting any code or almost any code and just compare, and iterate quickly. And then for your question about how to select models, how to compare models, the basic way to go when it comes to time series is backtesting. So, backtesting is more or less the way to do cross-validation, but for time series, meaning that you have a train set and a validation set, but you have to be careful that the validation set comes after the training set. So you make sure you basically don't cheat and don't train your model on future data. And then you can slide these two data sets in time and you simulate the process that you would have if you were training your model and evaluating it on unknown new data over time. So you simulate the process of constantly retraining your model on new data as you observe it. And this you can do it in Dart. As soon as you have a model, all the models have a backtest function. So you can just call backtest on any time series that you want and you will get results. You can either get the actual backtest forecast, so the forecast you would have had if you had used the model in the past, but also you can just simply get some aggregate metrics that can tell you in a number if a model is better than another.
So using those tools, you can pretty well benchmark the different methods against the data available, which of course you always need to do because there isn't a one best method. It's going to be case by case. Have you seen that any of these methods, given that it's so easy to try the same set of methods on one data set, do you find that there are a leader of the pack? Is something constantly dominating this? Is the neural networks taking over? Or do you maybe find in your experience that depending on the data, you really do see a preference for one model or another?
I think here the story is that for most of the history, the classic methods were really a good default way to go. So, the ARIMA, the exponential smoothing would be the very good default choices, and they would work better than neural networks most of the time, because for a long time, all we had for time series neural networks were RNN and different flavors of RNNs like LSTMs. And those, they had great success on NLP, speech recognition, and so on, but they didn't seem to work super well very often for real-world time series and forecasting problems. So we do have RNNs in Dart, and sometimes they work great, but I wouldn't say they are really, the good default choice. Now, there is, let's say, an upside for the deep learning aficionados. There are new models that are very recent. One of them is called NBEAT. which are very promising and they tend to work really well. So here, which model to go for always depends on many criteria, like the amount of data you have. That's one. But if you have lots of data, this model and it seems to be also a very good default choice. And if you are in low data regime and you have, very, I would say, classic forecasting problems with high seasonality and some sort of easy trends, then I would say the exponential smoothings are the way to go.
Seems like good advice, yeah. Presumably new methods may come out in the future. Perhaps I'll have to have you back on when we can say, oh, there is a neural network model that now wins all the benchmarks. I don't know what the future will bring.
Actually, that's sort of the case for this NBIT. So, there is the famous competition, maybe you heard of it. It's called the M forecasting competitions. This competition is decades old. So there was, I presume, M1, M2, also M3, M4. Now I think they are at M5. And since M4 was huge. They had, I think, 100,000 time series to train on and to forecast. And M5 was somewhat big, but not as big, I think. And in the NBIT's paper, they actually show that they do get state-of-the-art performance in those forecasting tasks for M4, which I think is maybe the most challenging competition so far that I know of. And I think that's quite a big deal because before that, the winners of that competition, the state of the art for this M4 competition, were a mix of classic methods augmented with machine learning methods, but not deep learning. And this NBITS model, really the interesting thing is that it's not fine-tuned or handcrafted to this competition. It's just a generic deep learning architecture that you throw at it, you let it learn on the tens of thousands of time series. It gets very accurate.
One of the things I liked about darts is how it's inclusive of a lot of more recent developments like that. How do you plan to stay ahead if there's the latest and greatest a year from now? Can that be included elegantly into the library as well?
Yeah, we'll try. At the moment, it's not a commercial project. There is no plan to make it commercial. We want to keep it the way it is, to keep it open source. But of course, that means we'll have to see exactly what amount of efforts we can put into it. But I think so far we have a good momentum. We have also a pretty good team working on it. And we are actually a few people working on this project. So I think right now we have manpower to follow what's happening and to also implement new models. It takes work and effort. So I hope we will be able to do that again in the future, to do that in a sustained way. Yeah. But open source projects, they are hard to, really maintain on the long term. So it's also about building a community and not working alone on it, right? So you can also make it alive in a way.
Thanks to this week's sponsor, Linode. I first became a Linode customer a long time ago when I bought one of their bare metal cloud servers. It was great for my needs. But Linode's got a lot more to offer. With Linode, you can build, train, and scale machine learning and AI workloads with powerful NVIDIA cloud GPUs, dedicated AMD processors, and free bundled transfer. Say goodbye to proprietary services, unpredictable bills, and contracts that lock you in. Pay only for the computing power and resources you need for both short and long-term projects. Plus, you'll pay the same price for compute instances in any of Linode's 11 data centers, serving all global regions and receiving award-winning 24/7 365 human support. Whether you're a company that needs to shop around and save money, or an independent developer looking for an affordable, accessible choice, use that link and they're going to give you $100 in free credit just for Data Skeptic listeners. Visit linode.com/dataskeptic and click the Create Free Account button to get started. I see that community really growing as I check out the GitHub page and look at issues and PRs and stars and things like that. Can you give just a summary of some of the engagements you've seen since the project started?
Sure. So actually being contacted for a podcast is one.
Oh, I'm your first then. Wonderful.
You are not exactly the first. We had a little bit of echo in some of the online media already. But I think for me, the most striking engagements that we're seeing is really people that basically we don't know who are using the library. Right now, there are quite a few people we don't know using it. But, the first time it happens, it's a special feeling. For me, it's the first open source library that I create and work on. And when you see that it actually becomes helpful to other people, it's a really good feeling. And now we see, on Stack Overflow, for example, there is a Dart tag and people are asking questions and other people that we also don't know are replying. And there is something going on there, which is really cool.
That's great. Yeah, I'm not surprised because in my personal experience, I find the library incredibly easy to work with, especially given that I'm already familiar with the sort of standard sklearn fit predict model. I've worked with some of these other tools in the past. There is a bit of a startup cost in getting them configured, installed correctly, all of that stuff, and Darts really took that away. So, very good work in that regard from my point of view. I'd like to unpack a little bit of if there's a cautionary tale here. Time series work, while everyone kind of has a time series problem and would love to just have time series as a service, give me your data, I'll give you back the forecast. With inside that black box, decisions are being made. So I guess, as I use Darts, I get to pick my model and I get to pick its parameters and that sort of thing. But do you also see maybe an area where someone who doesn't know how to tune those things could just kind of use a sledgehammer and come out with a spurious result? Are there maybe best practices or anything to be followed before using the tool?
Yes, definitely. Actually, this is a very interesting direction and one that's on our roadmap. So basically having a sort of, I would say, higher level API that you can just call with your data and sort of as a maybe non-expert user, hope for the best and get decent forecasts, without even knowing about the different kinds of models or anything like that. And I think this definitely should exist, I hope we'll be the ones to do it. And here, yeah, it's a very promising directions, but there are some care to be taken. So, time series forecasting, depending on the problem size, very often is actually a fairly dangerous exercise in terms of overfitting. So it's very often very easy to overfit, especially if you work on toy problems on one time series or a few time series. This is very small data often, and that means that, if you are just sort of trying to automate away the model selection part and iterate over many hyperparameters and many kinds of models and etc., I think this is dangerous. I think it's very likely you will just overfit, So here, I think it will be about applying basically sound scientific process and sort of tame the statistical power a little bit to the problem size, also in an automatic fashion.
Well, with the project being open source and so easy to install, I know you don't necessarily have any insight into the variety of places it's being used, but I'm curious if you have heard back from any users, particularly those maybe applying the tools in ways you weren't expecting.
Right now, the main way we hear back about the usage of the tool is mainly through issues, so things that don't really go well or go as expected. And unfortunately, I'm not sure they give, a totally fair picture of how users are using the tool. So if any listeners of the podcast is a user of Darts, please, get in touch with me. I'm super eager and curious to know about how you're using the tool and what you use it for. But I think among the domains where we know that we have users, there is the energy sector, and I think financial sector also, we have seen usage of Darts in those two sectors mainly.
Yeah, energy was one. I'd watched a video with one of your colleagues about darts that kind of surprised me. I guess just a symbol of my lack of creativity, but that power companies, this is very important for them because it's hard to store. So they have to kind of produce on demand. So forecasting is very important.
Yes, I think forecasting is a good fit, especially when you're looking at, recurring patterns, obviously. So things like rainfalls or sunlight, for example, for energy production, those are, I think, good candidates. There are other domains where, in general, forecasting is more of a dangerous exercise. For example, I wouldn't throw just a forecasting model on the stock market, for example. I don't think that's a really good idea.
Well, maybe not a good idea for practice, not one for investment purposes, perhaps.
Yeah, maybe it's almost perhaps a philosophical question, but I think you need more data than just the history of the stock market to make, relevant prediction that would make you money on average.
Yes, I very much agree, as much as it might be a distraction. I share your point of view on that for sure.
Oh, it's fun to do. It's fun to do for sure. So, as long as you don't bet everything on this, I guess it's fine.
Well, and if you only pay attention to your bets you made that won, it looks pretty good.
Yes.
I was wondering if we could talk briefly about backtesting. You'd mentioned it as sort of the machine learning equivalent of cross-validation kind of, but for time series. How does the library help me make sure I follow that properly?
Mainly through the usage of the backtest methods. And here it comes in two flavors. So in its basically rawest form, it's called historical forecast. So each model has this function. So that means any forecasting model that you have in Darts, you can call, model.historical forecast. And this will do the whole sliding window logic for you. So that should basically, I think, ensure that it's done correctly for you. And then every model also has a model.backtest function. which returns metrics. So you just say, okay, I'm interested to compute the RMSE or the mean absolute percentage error, for example, on my time series. And it also does the same, sliding window logic for you. I think that's the best way to go. And if, we are working on extending this functionality, so it can be done also automatically on data sets of time series, not just isolated time series. So this will come in an upcoming release normally. But I think it's fairly simple. At the end of the day, it's a function call and it should do it for you.
So from a point of view of there was a need for a good Python library to elegantly wrap these tools up, I can understand the motivation to build darts. Were there more commercial motivations? Was this something to help in your everyday work life as well?
As I mentioned, we built it a little bit out of frustration because in our daily work at Unit 8, we pretty often have to work with time series and we pretty often have forecasting problems. And, we didn't want to every time have custom code that has to call stats models or build our own PyTorch models when we want to try, LSTM or whatnot on a new problem. So yes, definitely there was a motive like that to just make our life easier. I wouldn't say it was directly commercial, it was more like out of convenience for us. And then we just thought, okay, let's just open source it. Of course, the day we decide to open source, it also means working a little bit more to make it a bit smoother to use, have good documentation, etc., everything that comes with it. But that's it. There is no big commercial motive behind. I mean, we are super happy, of course, if it brings a bit of attention to our company, if it attracts new customers or prospects. That's really good, but it's not really, the end game, I would say.
Yeah, I guess when a moment ago I said commercial, maybe I should have said something like ergonomic. I meant that it was seems to be informed by real-world use cases you guys had.
Yes, exactly. That's totally the case, yes.
So I think that's a great way to build a product because you have your baked-in customer in some sense, so you're making informed decisions. Were there any ways that you can say that tangibly shaped the design of the library?
You mean the fact of having already use cases that we're working on?
Yeah, you weren't building this to follow a textbook. You were building it to solve a real-world use case.
Yeah, I think it did because we did, at least at the time, a little bit of research, right, to already see what's there. And there are some great time series libraries, also, other ones that are doing great things as well. But we didn't really find something that would be as convenient for us for this sort of quick iteration on forecasting problems as Dart is. So yes, I think it informed the process. And, we didn't originally really optimize for having a successful open source library, right? And I'm not even sure it can be called successful today, but maybe it's somewhat successful, but it wasn't really optimized for that. We just optimized it to have something convenient that we would enjoy work with.
Well, yeah, and that seems to replicate pretty well, at least in my experience. Well, I'm curious, what's next for the library? I mean, it's sort of at a place where it's useful to me and to, I think, lots of people. Maybe there's not much more to be done, but do you have a vision, if anything, for what comes next?
There are lots of things that I think would be very nice that we have on the roadmap. Maybe not everything might turn out super useful, so we have also to, I think, observe and learn from users. But among the main things, first, I think we still have to improve a little bit on some of the details of how neural networks are handled in darts. I think the current way they work is great, but we are basically mapping, I'm going in the details now, but we are basically mapping all the neural networks models into sort of block architecture, which is sometimes a little bit ignoring the fact that, some of these models, like the transformer, for example, are meant to actually work different than that in more like a sequence fashion. This is really a detail, but I think it will make a difference for the users eventually when we, smooth this out a bit or basically extend this functionality a bit and handle it a little bit better. I think we can also do a bit better job at handling certain kinds of covariate data. For example, future covariate time series that you know at the time of prediction in the future, or also external data that's not necessarily in a time series itself, but that you want to condition your forecasts on. That's things we want to include. And then on the bigger topics, we are thinking of extending darts to capture probabilistic time series in certain ways. The basic use case here is to have confidence interval in the forecast. That's the basic thing. But then we can also, obviously think of that as a way to also, for example, do anomaly detection, especially if we have fairly good way to represent distribution of time series. And yeah, I think those are the main items on the roadmap.
Is there anywhere people can follow both the project and you online?
Sure. So right now we don't have really anything else to follow the project than the GitHub page. So this is the best way to go. We are sometimes writing blog posts about it, but these ones you can look at them on our company website, which is www.unitate.co. And you can also follow me on Twitter. This is JLHRZN.
Very cool. I'll have links to all that in the show notes. Julien, thank you so much for coming on to share your expertise and your work on this project.
Thanks a lot for having me, Kyle.
That concludes this installment of Data Skeptic Consensus. Our guest this week was Julien Herzen. Claudia Armbruster is our associate producer, Vanessa Bly does guest coordination, and I've been your host, Kyle Polish.